Good morning and welcome to Wednesday's Maths. So we're working with ratio this week. I think we'll find it quite easy. It's just a bit of a rewind to get us ready for secondary using lots of different representations so that we are confident with them when we see them next year. So we're still working at ratio today, but we are using multiplication and division. So we're looking at different combinations. So if you had one coat and one hat, how many possible combinations could you make? Well, you could just make one. What about if you had one coat, but two hats? How many combinations could you make then? Well, now you can make two combinations because you can have the yellow hat or the blue hat. What about if you had one coat, but three hats? How many combinations would you have then? Well, now you would have three combinations because you can have one coat with the yellow hat, one with the blue hat, and the same coat with the red hat. So you can have three combinations. Right, we're going to have a go at working this one out. How many different outfits can you make now? So you've got two coats and three hats. Pause the video, off we go. So this time you can make 6 different outfits because you can have the yellow coat with all of the hats and you can have the blue coat with all of the hats. So you would have 6 different outfits. If Megan chooses the yellow coat, there's 3 possible hats. If Megan chooses the blue coat, there's 3 possible hats. So for every one coat, there are 3 hats or possible hats. And if there's 2 coats, there's 6 outfits. So hopefully you can see how this relates to ratio because it would be 1 to 3 and 2 to 6. So all you've done is you've doubled that top ratio to get the bottom ratio. If we go back to this a moment, I want you to have a look at what do you notice. When the number of coats to hats is 1 to 1, the answer of combinations is 1. When the number of coats to hats is 1 to 2, the answer is 2. When it's 1 to 3, the combinations are 3. Now, if we look at the question that you've just done, this time we've got 3 hats and 2 coats, and there was 6 possible combinations. So what rule can we infer, can we reason about this? Well, hopefully you're starting to notice that if you multiply the number of coats by the number of hats, you're going to get the number of possible outfits. So when she had 2 coats and 3 hats, we multiply them together and there was 6 possible outfits. When it was 1 coat and 1 hat, it was 1 possible outfit because 1 times 1 is 1. When it was 1 coat and 2 hats, 1 times 2 is 2. When it was 1 coat and 3 hats, 1 times 3 is 3. Next question then. Emma is making party bags. In each bag, she puts a toy and a sweet. How many different ways can she create a party bag if she's got 2 types of toy and 4 types of sweet? So here's your 2 toys, here's your 4 types of sweet. How many different ways could she create the party bags? Pause the video, off we go. Right, answer time then. So for every 1 toy, there is 4 possible sweets. So we could write this as 1 to 4. 1 toy can go with 4 different sweets. But this time we've got 2 toys, so we've timesed it by 2, so we times the sweets by 2, which would be 8. So there will be 8 possible party bags, and you can see them all here. Look, here's the blue dinosaur with the 4 sweets, and here's the red car with the 4 sweets. Hopefully what you're also noticing with this is that you can multiply the 2 things together. So there's 2 toys and there's 4 sweets. So you can multiply 2 times 4 to make 8, and there's 8 possible combinations. So again, there's different ways of looking at this. So there it is written down. Okay then, I want you to have a go at this one. So there's 2 questions here. I want you to pause the video and have a go. Right then, answer time. So, for this first one, you've got 7 pairs of socks and 3 pairs of shoes. So, if we're working using the rule that we've worked out for the coats and the toys, you should be able to multiply the 2 different things together, and that should then give you the different combinations. So there's 7 pairs of socks, 3 pairs of shoes, multiply them together. 3 times 7 is 21. So there should be 21 combinations. Now, I want to prove this using ratio. So here are my shoes. They are shoes and not bumblebees, even though I know they do look a little bit like bees. So he had 3 pairs of shoes. So there's 1 pair. So I think the way for me to look at this is to work out how many combinations there is with 1 shoe, first of all. So there's 1 pair of shoes, and there's 7 different socks that it can go with. So it's 1 shoe to 7 socks. Then I've got another shoe and another 7 pairs of socks, another 7 combinations. Then I've got another shoe and another 7 combinations. So what I can write this as is I can write it as 1 shoe to 7 combinations. I'm just looking at one of these. Okay, so you've got 1 shoe to 7 combinations. That's the most basic ratio when looking at the shoes. So 1 to 7. But then I've actually got 3 shoes. So I need to times this by 3. So then as we know, we need to times this by 3, which would be 21. There would be 21 different combinations. Now, the other way I could look at this is I could have looked at what about if I looked at 1 pair of socks first of all. So 1 pair of socks has got 3 possible shoe combinations. But there's not 1 pair of socks, there's 7. So I times this side by 7 and I times this side by 7. So there's 21 different combinations. So I've shown this 3 different ways now. So for the first one, you should have got 27. Well done if you got that right. Right, for the second one then, I've got team A and I've got team B. So if I use the rule that we've been using, if you multiply the 2 things together, you should get the possible combination. So if there's 5 people on each team, 5 times 5 is 25. So I think there would be 25 handshakes. Let's see if I'm right. Well, one team, so team A, have got to shake all the hands of hands B. So let's say there's 5 people on team A and the first one's called Jill. So here's Jill, and Jill is going to shake hands with 5 people. So that would be the basic ratio. But there's not just 1 person on Jill's team, there's 5 people. So I need to times this by 5 because there's 5 people that need to shake 5 hands. So I need to times that by 5 because they all need to shake 5 hands. So it would be 25 handshakes, which is 5 times 5. So I know I've got it right. For the next one then, there's 11 people on the team this time. So I can say 1 person has got to shake 11 hands, but there's 11 people, so a times by 11 times by 11, 11 times 11 is 121. Well done if you got those right. Okay then, last 2 questions for today, but I think we'll find them nice and easy. So have a read through, write down your answers, and then we'll go through it together. Right then, answer time. So for this one then, ratios maybe not the easiest way to think about this, but this is all about the total, okay? So the total combinations of 6 different t-shirts and a certain number of trousers is 24. So this time I'm going to use the rule that we looked at earlier. So 6 times what is 24? Well, it's 6 times 4. So that tells me there should be 4 trousers, and 6 different t-shirts. And for the second one, again, I'm just going to use the rule that we looked at earlier. So we know that the number of boxes times the number of toys is going to be the different combinations. So we know there's 2 boxes. So 2 times something is going to make 24. So what's 2 times what makes 24? What's 24 divided by 2? 12. So there's 2 boxes, each with 12 toys in, and together it would make 24 different pairs of toys. Really well done if you got that right. Okay, that's it for today. Nice quick lesson. Have a go on TT Rockstars or hit the button. Keep practicing those times tables. See you tomorrow.